Okay, so firstly, I just wanted to say thank you so much for having me. It's an absolute pleasure and an honor to be here among so many great percussionists and a lot of my heroes from years past, as well as those of you who I haven't seen for a few years. It's wonderful to be here. And it's been absolutely eye-opening. There's been some really stunning performances and lectures. So I just want to say thank you to the organizers and to all of the staff who've been so helpful for this whole process. My name is Andrew Blanton. I'm a percussionist and a new media artist. I am in the Department of Digital Media Art at San Jose State University. Today, I will be presenting work around feedback-based performances for percussion using real-time audio visualization and visual analysis for sound production. That sounds incredibly academic when I put it like that. But basically, I just want to talk about this idea of where my percussion practice went to, and what the things that I started doing, the things that I found interesting in my percussion practice. So I started thinking a lot about the human body and the phenomenology of the human body and the way we perceive the world around us. In particular, how we as percussionists use our sticks as extensions of our bodies, maybe something of a prosthesis. And this is sort of like traditionally true throughout the history of Western classical music, right? Musical instruments can be thought of in a way as a prosthesis or an extension of the human body. That's the way I think about my instruments anyway. And maybe my sticks are some sort of intermediary device. And so with that, I started thinking a lot about how I could extend the voicings of my instruments and what types of processes I would use. I had a family of engineers, so I had a bit of experience with software development when I was growing up, and I decided to hybridize those forms to take more of a transdisciplinary approach to classical percussion. So could I create software that would extend the voice of the instrument, that would extend my body in this same way through virtual realms? So today, I'm going to essentially attack this in three parts. So there's the technical component, both from the percussion aspect of it, as well as the software, hardware aspects of it. The conceptual, the why am I doing this? Because I think that's a really interesting question. And the performative aspects of it. How is this implemented, and what are the things around these ideas that are important? I'm going to focus on two works. I had three sort of initially scheduled, but I think the narrative runs a bit cleaner if I just sort of refine that and focus in. We have sort of plenty to talk about within these two works, and so it would have been torture to try and get through three. I'm going to talk about one work, Modulator, and then I'm going to talk about the sort of another framework that I've been working on called Mystic Talent. So the first thing to note when focusing in on Modulator is that I got really into, I started by saying that I got into this extension of the voice of percussion. And I would do so, like, I think first I, got, I don't know, like a billion piezo discs and started wiring them to my marimba, right? Or at least rubber banding them to bars, because that's the best way to do it. Using piezo discs attached to vibraphones soldered onto bars, which is also another really interesting approach, but I found that dampens the keys. So then I moved into something like overhead microphones for my percussion rig. And that was also interesting. And that got me into this idea of real-time sound feedback. And so I had been working on this idea of these audio chambers for either maybe installation or for performance, because they sort of work in two fashions. And I'm really interested in how other people interact with these environments as well, not just my own interactions with them. This led to the development, I think in something like 2010 maybe. I was working with a particular library of pure data called libpd that Reiner Kramer introduced me to, which was wonderful. And so I started with my first app for porting these real-time sound environments into mobile devices, which was standalone V1. And I guess, just to back up, I started with this other library that was developed at the Princeton School of Music called Novocaine. And that tended to be like fairly painful. So anyway, moving to libpd was much more successful for this reason. But again, I was working on this idea of cross modes of perception, right? So maybe if we as humans have, I don't know, a basic understanding, like 5 modes of perception maybe, right? That would be touch, taste, sight, sound, smell, this sort of thing. Maybe our spatial orientation to the planet, things like this are also the way we perceive. But I was interested in how do we take a phenomenological approach to that, and maybe could I express one gesture or one form of perception through another form of perception? So these came into an exploration of devices, and these create a real-time sound field. So what happens? The interesting part about this is that if I put this down, I actually get tactility of the sound waves. So that to me is really interesting, right? Because without touching the device, I get a physical interaction with the sound waves around me. This somewhat reminded me of, my experience with maybe a membranophone, if we want to use that type of term. These drums with membranes on them, because I have a lot of physical interactivity with the sound waves, maybe something like timpani, where we have these waves flowing through the drum head. So in building these performance environments, this is also made for installation, where I can have it installed in these big areas. But that led me to a little bit more of an in-depth approach. So in 2012, I went to STIM, which is the Studio for Electroacoustic Music in Amsterdam. And at STIM, it was interesting to be in the basement because they sort of have the history of analog synthesis down there. And I found that actually within analog synthesis, there's a lot of the same paradigm challenges that we face in mobile computational platforms, right? So I started working with the matrix synth in the basement. And that led to this second device that I built, which is called Modulator, that I'm talking about. So this is just all as a background, right? And this device works in the same way by building these, but I extended the device to actually take in sensor data from the device itself also. So other than building out these sound chambers in real time on mobile platforms, it's kind of like, these are sort of the areas that I was exploring, and I was putting these into bigger environments to perform with drums in. So it's like creating a real-time feedback loop on bigger stereo systems and then inserting the performer in the middle, which is where this all sort of started. So just to move forward, we could talk about the second work today, which is this framework that I've been working on. In a lot of ways, Mystic Talon is a combination of software plus visuals. And so again, through that exploration of cross-modality, how do we express one sense with another sense? Maybe how do we express sound with vision or vision with sound? I was interested in creating these feedback loops except within the software itself. So for this framework, I have a number of important components, but the broad scale of it, the idea is that I start with input from the drums. I put that into the software. I do real-time analysis of the software, or of the drum input, and then in 2 ways I can visualize that sound, and then extract sound out of that visual, and then send that sound back into the software. Does that make sense? Everybody with me? Okay, no, we all got lost somewhere in the technical details, right? You're like, great computers, dude. Okay, so anyway, I mean, just, this whole, that's exactly the question of why. Like, why would I ever want to do this, right? I will just follow up by saying there are three primary components to this software that I've been developing. So this is sort of the broad scale interface, or the broad picture of the interface as it is. And so basically I have three major components, right? I have one component that brings drum signal in, and I analyze those in two ways. So I do threshold analysis, which is saying if there is an attack, fire out a trigger, or I also bring that raw drum signal in and use that raw signal for signal processing. So this is somewhat different from using, like, say, for instance, a drum brain that would already be built. I hope my computer's not getting too hot. So anyway, the second major section is the audio synthesis portion of it, which I'm also doing in a lot of different custom synthesizers that I've built, and I can call those on the fly using the dispatcher object. So I tend to think about these software packages as like growing an arm in real time and then retracting that arm if I need it. And this is entirely for computational power within the software package. The final component is the raw data feeds that I'm sending out to Unity, which is what I'm using for the visualizations. So Unity is a game package. It's made for video games. And it just so happens there's like an army of 14-year-olds working on it, optimizing the code. So it tends to work really, really well, especially on mobile computers. So yeah, I just wanted to talk about that modular design. I'm using Unity plus Max with a library called Mu, which was developed at the Virginia Tech University in the School of Music there. So anyway, that's sort of the background on these works. I'll talk about three different sections now. I'll provide vignettes of those sections so you can see sort of how they work. And these three sections, the first one will demonstrate mostly just triggering. So this first section, I guess there are some important components to talk about here. Basically, the 3D scene that I'm working with is an Intel Montecito chip, which is really interesting to me conceptually because it was the first time they used full-scale automation or actually it's a procedural automation to develop the way that the ones and zeros were flying through the chip. That's kind of interesting. That happened in 2006. And I was reading a paper on architecture that was comparing basically the way information flows through the human brain, Intel Montecito architecture, and the development of urban environments. So can we start to develop urban environments in this procedural way? That's expressed through procedural animation. And that ties sort of into some of the brain research that I've been doing, but that's for another talk, as I said. The next two sort of vignettes or outlines of these pieces I wanted to show are also dealing with procedural animation. Now you'll notice that within those, you could hear sort of the backgrounding sounds, I don't know, sort of like high-pitched chimes. I don't know if you heard those out there. But that was all being extracted directly out of the image. So I'm doing real-time processing of the image to extract sound out of, right? Drums into image, image extracting sound. Now, I've taken that a bit of a step further, and I also included basically real-time delay lines and then feedback into the model in this second and third model that I want to show. So within these environments, I tend to think of them as accompaniment figure to the percussion, and they act as extensions of the drums, which is mostly what I'm interested in nowadays. To think of this idea, again, how do we express the sounds that are coming out of the drums digitally? How do we have drums interface into these mediated environments, which is somewhat of a reflection of contemporary society for me. So this idea of, like as a drummer, I don't want to spend too much time building software. It seems like an awful idea most of the time. But I do think, for me, a lot of the benefits are there. And I think sometimes it's well worth it for some of the images and looks that I can get. So, with that said, I guess the last thing that I wanted to say is that none of this stuff exists in a vacuum, right? I built all the software myself in these frameworks, and I've tried not to commit any crimes against either art or sound, which was also important. So yeah, I basically controlled, or I built everything, and it's all what I wanted it to be for the most part. But I will say that there were a number of historical important people that I was looking to do this, and as well as like the libraries of MaxMSP, of Pure Data. Those are incredibly important for artists to begin working with. And also some of the historical perspectives of visual music and how music can be expressed through visual means was also very important. So anyway, with that said, I guess that's where I'll wrap. Cool. Yeah. Thank you.